This is part of the lecture for multivariable calculus, and we are going to talk about planes. How to find equations of a planes when we have a point and the normal vector, meaning that a vector perpendicular to the plane, and writing equation of the plane using three non-collinear points on the plane. So let me start. A plane has equation like this. So it would be ax plus by plus cz, and it's equal to d, where a, b, c, and d are just numbers. So geometrically, we need one point, so a point on the plane, and also we need a vector that is perpendicular to the plane. Okay, a vector that is perpendicular to the plane, it's called normal vector, and we show it by capital N. Okay, let me give you an example, and I'm going to explain it through the example. So a plane, we're going to write equation of a plane through the point. I'm going to show it by P0, 2, 1, negative 1, with the normal vector 3, 5, and 10. Okay, so I have a point P0 and I have a normal vector n. Okay, so this vector n is perpendicular to the plane, meaning that it's orthogonal to every vector that I have on the plane. So I'm gonna pick just one point with x, y, and z, and then I'm gonna say that the vector n is perpendicular to this vector p0 and p. So I have p0p orthogonal to n. So meaning that p0p, this vector, dot product with n, the dot product of two orthogonal vectors, is 0. Okay, so p0p would be the coordinates of p minus the coordinates of p0, so it would be x minus 2, y minus 1, and then z minus negative 1. Dot product with the vector 3, 5, and 10. So it would be, this dot product is 0, so it would be 3 x minus 2 plus 5 y minus 1 plus 10 z plus 1, it's equal to 0. If I want to simplify it a little further, it would be 3x plus 5y plus 10z, and I'm gonna bring all the other numbers on the other side. So I get negative 6 minus 5, so negative 11, plus 10, negative 1. I'm going to bring on the other side, so I get 1. This is exactly the equation of the plane, as you see in here. So if I want to generalize this situation, I can say that equation of a plane through the point P0, which is x0, y0, and then z0, that's with orthogonal vector or normal vector n, a, b, c, is equal to ax plus, actually, let me write it like that, a x minus x0 plus b y minus y0, and then plus c z minus z0 it's equal to 0. If you simplify that, we get this: ax plus by plus cz, and it's equal to ax0 plus by0 plus cz0, and this is just the number d. Okay, so we usually use that one. Now there is another way to write the equation of the plane using 3 points that are not in a line. So I'm gonna talk about equation of a plane through 3 non-collinear, the 3 points that are not in a line in the plane. I'm gonna show it by an example. So a plane through these 3 points: 3, -1, 2, 8, 2, 4, and -1, -2, and -3. Okay, so I would like to this plane passing through these 3 points. So I know that if I have a normal vector with a point, I can find equation of the plane. So all I need to do is to find the normal vector in here. How do I do that? I just graph the vectors that I have in here. I know that cross product of 2 vectors is a vector that is perpendicular to the plane that passes through them. So the normal vector would be the cross product of these two, AB cross product with AC. Actually, they should be these two should be at the same beginning point. So I need to find AB, I need to find AC, and then the cross product. So AB, the coordinates of B minus the coordinates of A. So it would be 8 minus 3. Let me write everything: -1, and then 4 minus 2, and then cross product with AC, the coordinates of C minus the components of A. -1 minus 3, -2 plus 1, and then a -3 minus 2. So to write the cross product, I'm gonna find the determinant of this matrix: 5, 3, 2, and then -4, -1, and then -5. So it would be I times I'm gonna remove the row and column that contains I, so I left with -5 plus 2, which is I'm sorry, -15 plus 2, it's -13, and I'm gonna do the same thing: -j 17, and then plus k 7. Okay, and now I have the normal vector. I can choose just one of these points, so it would be -13 x minus 3. I choose point A. Minus 17 y minus -1 plus 7, and then z minus 2 equals to 0.